This is an updated demonstration of Face Forensics' unique tattoo recognition software. The system I'm going to demonstrate is designed to identify a specific tattoo even if it's been partially obscured, heavily cropped, or faded with age, enabling the owner to be identified by matching it against a database of tattoos. Before I get into the detail, let's look at it in action. The system has three main functions. The first is to connect to an existing database, view the tattoos in it, and search the database for a specific tattoo. If a database containing tattoos already exists, F2 can map onto the fields it requires in it and search them directly, so there's no need to set up a separate database for F2 to search. We're already connected to a test database. We can scroll through it and look at the individual tattoos in it. When a database is first connected, we can enroll all the tattoos using the Enroll All button down here. So when we match a tattoo, we match its numeric string against a database of numeric strings. These strings are held in server memory, so while encoding an image takes a couple of seconds or so, it can search them at many thousands of tattoos per second. For large databases, the search can be spread across multiple processors. Now we can go to the search screen. The area on the right is where we can drop in an image of a tattoo, while the black area on the left is where the top matches will appear. I'll drop in a tattoo of someone's lower leg. When I click the Recog button, the top matches will be determined, sorted into match percentage order, and displayed on the left, together with the name of the tattoo's owner. Encoding a tattoo is highly complex because it can be an image of just about anything. It doesn't have predictable features like eyes, as in the case of faces. It can be anywhere in the image, and it can fade over time. In this example, the top match is a different shot of the same leg taken around the same time, with a 35-degree difference in the angle of the shot. The 86% match here is due to the different angles displaying different visible characteristics of the two images. Depending on where we set the recognition threshold, non-matching images may be displayed as well, as in the case of the one shown here. These will have some characteristics which are similar to the probe image, although visually they may look quite different. This doesn't really matter. When officers look at them, they'll ignore visually dissimilar matches anyway. F2 can compare any possible match side by side with the original and magnify them both. So here we have them both together, and I can use the scroll wheel on the mouse to magnify them so that an investigator can see the detail that's required. So the benefit is that instead of having to look through thousands of images, the officer only has to look at the top result and those close to it to confirm a match. The next example is a pastel pattern that's faded with age. When I drop it in and click Recog, you can see that it's a partial shot of a larger nondescript pattern. The system has nothing much to work with, but it still finds the correct match. In many cases, a tattoo can be both partially obscured and faded. I'm going to show you how F2 handles this while combining it with a further challenging task. We often get asked if F2 can handle the blurriness that can happen when tattoos get older. Here's an example that includes both. It's basically impossible to make out what it is. However, when I click the Recognize button, you can see that it's part of a fuzzy tattoo of a tiger. Here's the area that is in question. It's around there. To match this, F2 has to check every part of every image in the database. Here's the area covered by the probe. It's the center of the tiger's back. It still comes up top of the list. When a new tattoo is added to the external database, the system will automatically detect this, encode it, and add the resulting encode array to its own internal database of arrays. So F2 will always search the current version of the database. In terms of connectivity, the system is designed to map easily onto existing SQL Server and Oracle databases. There's no limit to the size of the databases that can be searched. F2 Tattoo is part of the F2 Image Recognition Suite, which includes face recognition, partial face recognition, corpse identification, and scene recognition. They can all link together. The software runs under Windows 10 and 11 and is available as an application, as a .NET SDK, and as a web service. If you're a government agency or an established supplier to them, you can download a copy and try it out at no charge. We'd welcome the opportunity to show you what it can do.